Select the best reagents to accomplish the following transformation. So if we look at what we are given here, we are starting with a chiral alcohol. And this alcohol, the alpha carbon has 2 bonds, 2 carbons. So this is a chiral secondary alcohol. And we have replaced that alcohol with this cyano group. And so we should pay attention to the stereochemistry because this looks like a substitution, right? We've substituted one group for another. And overall, the alcohol was on a wedge bond, so sticking out of the plane of the page. And now that cyano group is going into the plane of the page. And so that means we see inversion of stereochemistry, which makes us think about an SN2 process. And so alcohols are really poor leaving groups. And so if we want to do an SN2 substitution, we need to take that poor leaving group and we need to convert it into a good leaving group. And we want to, again, pay attention to the stereochemistry. So after we convert this into a good leaving group, then we want the cyanide ion to come in and do an SN2 attack. And so if we want to see the overall inversion, that means that in the first step, taking this poor leaving group and making it into a good leaving group, we don't want to change the stereochemistry. So we want to have this. So we want to start with this chiral alcohol, OH, right? And we want to make it into something that is a good leaving group. So I'm just going to say LG for leaving group. So I want retention of stereochemistry in this step, so that in the next SN2 step, when I throw in the cyanide ion, I can get the inversion that I want to see in the product. Okay, and so here, so this was a hydrogen. Let me make sure that's still on there. And so then here in the product, right, now we've inverted the stereochemistry. So definitely we need something that's a source of a cyanide ion, and we want a way to take an alcohol and make a good leaving group with retention of stereochemistry. And the way to do that is to make it into a sulfonate ester. So this is what indicates to us that we want to make a sulfonate ester, because when you make the sulfonate ester, you don't involve that carbon center, so it does not invert. So the first step that we're looking at here is taking this chiral secondary alcohol, and we're going to treat this with tosyl chloride and pyridine to make a sulfonate ester. And there are other sulfonate esters you can make, but this is a common one. And so when you do that, the alcohol itself, I'm going to draw a really quick mechanism. It's not exactly accurate, but it'll give you an idea. So it's the alcohol that's functioning as the nucleophile. This carbon's not involved at all. And so that's why the stereochemistry stays the same. And so then in the second step, if you throw in a cyanide ion, that's when you'll see the inversion of stereochemistry in this SN2 attack. And so the option that we want to select here then is D.